Okay, so for week 6 of the video homework, a hospital's asked you to design a solenoid for them that they can use in their MRI machines. They want the solenoid to be 0.75 meters long, have a current of 3 amps, and have a magnetic field of 0.002513 Tesla surrounding it. How many loops of wire do you need to put in the solenoid to fulfill their objective? So, to solve this, we know that the magnetic field of a solenoid is equal to mu naught times the number of loops in the solenoid times the current divided by the length of the solenoid. So then when we rearrange our variables, we get that the number of loops in the solenoid is equal to the magnetic field times the length divided by mu naught times the current. And when we plug in our numbers that the hospital gave us, we get that their solenoid should have approximately 500 loops. And then the hospital is so happy that you designed their solenoid for them that they give you another project. This time they want to know what the magnetic field of the same solenoid would be if it now had 900 loops. So using all the constants that we had before, such as the current and the length, we now want to know what the new magnetic field would be if the solenoid has 900 loops. And so to do this, we're just going to use the base form of the solenoid equation, which is the magnetic field of the solenoid equals mu naught times the number of loops times the current divided by the length of the solenoid. And when we plug in our numbers, we get that the magnetic field of this new solenoid with 900 loops is going to be approximately 0.004524 Teslas. And so now that we've done these two calculations for the hospital, they want to know what the relationship is between the number of loops in the solenoid and the magnetic field. And so to do this, what we're going to do is take the two magnetic fields that we had and take the two numbers of loops that we had and see what kind of ratio it gives us. And when we look at this, we see that 0.00452 is the magnetic field with 900 loops, divided by the 0.00251, which is the magnetic field with 500 loops, and that gets us a ratio of about 1.8. And then on the other hand, when we compare the 900 loops to the 500 loops, we also get a ratio of around 1.8. So that means that the magnetic field of a solenoid is directly proportional to the number of loops in that particular solenoid. So now, when the hospital wants to change their solenoids in the future, they can use this 1-to-1 ratio to calculate it. So you did a great job helping the hospital out.